Hello guys, good evening. Good evening guys. Today we'll be seeing continuous function. Hi. Actually the live is at 6:30. So let's wait for 2 minutes and let's start the live. Okay. So today we'll be seeing continuous function. So this is chapter 5, differentiability and continuity. In this chapter, we'll be seeing the continuous function today. So yes, let's wait till 6:30. Let's start exactly at 6:30, 6:31. So yeah. And yes, so continuous functions generally you'll be have like when you take continuous function, and this chapter mainly chapter 5, I'm not in specifically telling chapter 5, the whole calculus part, which is the chapter 5, chapter 6, chapter 7 and chapter 8, the different continuity, differentiability and application of derivatives, then integration, then application of integration. All four totally consist of 35 marks, which is really very important. And this continuous function, this concept is really very, very important in both your engineering examination as well as your board examination. So this is extremely important concept. So do listen to me and let's quickly get into the video. So here, first thing, what are they saying? Left, now they just like, we are going to define about left continuous. So before like talking about what is a continuous function. Hi Amita, everyone just tell me a quick Abitha. So yeah, everyone just tell me a quick hi so that we'll quickly get into the video. So I'll be able to ask questions to you like simultaneously. So now what is left continuous? So generally you call a function to be continuous and you will be talking about continuity or differentiability for a function. Okay. So let's see if your function, a function f is said to be left continuous. So if it is left continuous or continuous from left continuous or continuous from the left at x equal to c, if and only if. So when do you say a function is continuous from the left? So basically when you're having a number line and when you're having a point C here, and suppose this is your function. So from left of C is basically this point. So you say a function is continuous from left when I'm writing this conditionality in different colors so that you'll understand. When f of c exists, your function at the particular value should exist. Okay. Next, your limit extends to c minus. Limit, I'm just writing it as lt. You can write it as LIM also you can write, LT also you can write for limit. So limit extends to c minus f of x exists. So basically your left hand limit exists. And the next one, third condition is your left hand, I'm just writing LIM or LIT, both are correct as I already told you. Limit extends to c minus f of x should be getting the, you should be getting the value of your left hand limit that should be equal to the function value at the particular point. So basically if this is f of c, when you're approaching to c, it will be somewhat near your f of c and approximately it will be equal to f of c. So these three conditions you definitely should have when you say your function is left continuous. Okay, so if you understood it, just give me a quick fire if you understood the concept of left continuous. Yes. Yes, guys, give me a quick fire if you understood it. Yes. Okay, so now let's go to right continuous function. Okay, super. Let's go to right continuous function. It is exactly the same. So you say a function, you have a function f. So a function f is said to be right continuous. So what do you say? A function f is said to be right continuous, or what can you say? You can say a function is continuous from right, or continuous from right. So at x equal to c, this is very important. At what point you will be seeing, that is very, very important. So when do you say that? So let me draw a diagram. Same way, this is the point c and this is the function, for example. So from right side you have to check for the, yeah, continuous from right. Yes. So from right side, you have to check for the condition, like whether it is continuous or not. So what are the condition? First condition is your f of c exists. So basically for this, for your right continuous or left continuous, your f of c should exist. Then what about the other one? So it will be limit extends to c plus f of x exists. So basically limit extends to c plus f of x exists. Then what happens? Limit extends to c plus f of x should be f of c. So basically your f of x value approaching to c from right side should be equal to the value which you substitute in the place of x, that is c, that is the function value at the particular point c. So this will be your f of c. Basically when you approach to it, it will definitely be somewhat near f of c. If these three conditions are there, then definitely what you can say? You can say it is right continuous or continuous from right. Same way, this is left continuous or continuous from left. So if you're clear, just give me a quick fire emoji in your chat box. Yes. Yes. Quick. Can you please be quick and give it to me? Yes. Yes, quick, quick. Superb. So now in general, we'll be talking about the continuous. So you say your function is continuous at a particular point. So when do you say the function is continuous at x is equal to c? When do you say your function is continuous at x equal to c? If and only if it is both left as well as right. So your function should be both left continuous as well as right continuous. So in this case, at x equal to c, at the particular point x equal to c, both your functions should be left continuous as well as right continuous. That will happen if and only if your limit extends to c minus f of x, that will be equal to limit extends to c plus f of x, that will be equal to f of c. So basically if you have to prove your function is continuous at the particular point, so if they're asking a question to prove your function is continuous at particular point, what can you say? Your left continuous should be equal to your right continuous, or your left hand limit should be equal to your right hand limit, that should be equal to your function value at the particular point. So are you clear? So yes, are you clear? Are you clear? When you say, so this is the definition of a continuous function. This is the exact definition. So if they're asking you to prove if your function is continuous or not, you just have to prove this. Then that's all. Like that's all is enough to prove. Are you clear? Superb. Now we have seen the reasons for continuity. Now, when can you say your function is discontinuous? There should be some points why your function should be discontinuous. No. So, let me tell you. A function f fails to be a function f fails to be continuous at x equal to c. So it fails to be continuous at x equal to c for the following reasons. So for the following reasons. What are the reasons where you can say it is discontinuous? So basically, first thing, your f is not defined at x equal to c. Okay, which means that is basically I'm saying your f of c does not exist. So that condition, in that condition, suppose if you have a function and you find a function, then you say, like, you cannot find a function at the particular point, function value at the particular point, then you say your f of c does not exist. If your f of c does not exist, what can you say? Your function is discontinuous function. Okay, then suppose if your limit, so we have seen the function value at the particular point doesn't exist. What happens if your limit doesn't exist? Same thing. If either of your limit doesn't exist, then what can you say? You can say it is continuous. So the second condition will be limit extends to c, f of c does not exist. So now you can say whether you can have, the first question that comes in your mind is whether this is the right hand limit or left hand limit. So it can be right hand limit, it can be left hand limit, or it can be both the limits. So it can be any limit value. If either one limit value doesn't exist, your function is said to be discontinuous. So this happens if either the first one is what? The first one is limit extends to c minus f of x does not exist. So either that doesn't exist, or what can you say? You can say same way, limit extends to c plus f of x. Your right hand limit does not exist, doesn't exist. Same way, what can you say? Your next, what can you say? Your limit, your both right hand limit and left hand limit does not exist. Sorry, both, what can you say? They are not equal. They exist, but they are not equal. So you can say both limit extends to limit left hand limit f of x and your right hand limit f of x exist. If both exist, but here the main conditions, both should be equal. Your left hand limit and right hand limit should be equal. So what if I tell you that both are not equal? If I tell you both are not equal, you can conclude that it is discontinuous. So, but are not equal. So this is the second point, which is, I'm just writing this in different way. So this is the first point, this is the second point. So if either of one condition, like either if one is true, you can say it is discontinuous. The first point is true, you can say it is discontinuous. The second point is true, you can say discontinuous. If the third point is true, again you can say it is discontinuous. Now let's go to the third point. So here I'm saying my limit extends to c f of x. This exists. So I am saying my limits exist. Okay, both the limit exists, but what can I say? My limit value, you can say it any right hand limit or left hand limit. That limit value is not equal to the value of the function at the particular point. So in that case also you can say it is discontinuous. Now what about the next one? So our fourth one is basically I'm just expanding this one. So basically limit extends to c minus f of x exists. So this exists, but what can you say? Both should not be equal. So limit extends to c minus f of x is not equal to f of c. In this case, what can you say? It is not continuous. Same way, sorry, not this one. Just a minute. So now directly what am I doing? I am doing it for the next one. So basically it will be limit extends to c plus exists, but your limit value does not equal to your function value. Okay, so these are the conditions for your discontinuity. If either the first one is true, you can directly say it is discontinuous. If the second one is true, you can say it is discontinuous. If the third one is true, you can say the discontinuous. It is not necessary that it should just be just one value. Anything like in the four concepts, you can have anything which any point can be satisfied, and if only at least one point is satisfied, directly you can claim it is discontinuous. If you're clear, just give me a quick heart. Yes? Give me a quick heart. Yes? Yes, quick heart. Okay, so now let's go to the questions which we'll solve. Okay, so let's see. First thing is they're asking us to examine the continuity. That will be a question. Examine the continuity will be our questions. Okay, so now I'm having my f of x. My f of x is basically equal to x square minus 4 divided by x minus 2 if x not equal to 2. Suppose, and if it is 4 if x is equal to 2. They are asking us to examine the continuity at x is equal to 2. At this x equal to 2, they are asking us to examine the continuity. So first, for this, I have to take my left hand limit and my right hand limit, right? So I have to take my left hand limit and my right hand limit. So first let me write. So my left hand limit basically limit extends to 2 minus. 2 minus, what does it mean? Basically it is less than 2. What is 2 minus? It is basically less than 2. So what will it be? So less than 2 or greater than 2, your function value. Basically here it is just given x not equal to 2. X not equal to 2 means it can be greater than 2 or it can be less than 2. Okay, but it cannot be equal to 2. So here limit extends to f of x will be equal to limit extends to 2 minus, I'm not writing because I'm writing the function value. So function value for x less than 2 is this one. So what can I write? I can write it as x square minus 4 by x minus 2. Okay, now what am I doing? In above thing, I'm having a square minus b square formula. So basically limit extends to 2 x minus 2 into x plus 2. So basically a square minus b square is a minus b into a plus b. Like this we can write divided by x minus 2. So now what, I am cancelling these two. After cancelling, what will I get? I'll be getting limit x tends to 2 x plus 2. This is how I'll be getting. Now what, I will be substituting the x value. My x value is 2, so 2 plus 2, so basically it is 4. So it is limit x tends to 2 minus f of x is 4. I got. Now what should I check? I have to check for my right hand limit value. So limit x tends to 2 plus f of x. As I already told you, your function value will be this only, because here it is given for x not equal to 2. So if it is greater than 2 or less than 2, 2 plus means x is equal to 2 plus means basically it is greater than 2. Okay, so limit x tends to 2 x square minus 4 by x minus 2. Like this it will be. Again what am I doing? I am writing, I'm just splitting it and writing. Okay, I'm just splitting it and writing. So now what happens? This and this gets cancelled. After cancelling it, what will happen? It will be limit x tends to 2 x plus 2. Now what am I doing? I am substituting the value of 2. So it will be limit x tends to 2 plus f of x is equal to 2. Now what should I find? I have to find at x is equal to 2. What is my point? My f of x is equal to, at x equal to 2, what is my f of x? Is equal to 4. So that is my f of at x equal to my f of x is 4. Basically my f of 2, it is given as 4. So from this what can I do? I can say my limit x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x, that is equal to f of 2. So from this tabular column what can you say? From this you can definitely say it as it is continuous. So therefore f is continuous at x equal to 2. So at x equal to 2, my f is continuous. So are you clear with the sum? Are you clear with the sum? Yes? Ma'am, you have written x plus 2. Where? Where did I write x plus 2? Yeah, 2 plus. Yeah, this is limit x tends to, this is right hand limit and this is my left hand limit. That will be equal to my function value at x equal to 2. Are you clear? Before that, where did I write? Where did I write before that? I'm not understanding. Where did I write? Next slide up. This slide up, where did I write? I've written 2 minus only, no? Where did I write it? Next. Next also where did I write? 2 minus only, right? Yes? Last slide. Up. Last slide up. Are you talking about this one? I'm not getting exactly what you're talking. Where am I talking? Can you tell me which slide? This is slide 1, slide 2, slide 3. Which slide? Which slide are you talking? slide 3 in top I have written 2 plus. You're asking why. I have written x tends to 2 plus left hand limit, right hand limit, no? Step 1. Slide 3, step 1. This is my step 1. Sorry, I'm not able to get exactly what you're telling. Can you just message me? Can you just message me like by taking screenshots of it? Okay, I got it. Yeah, this is 4. Yeah, I got it. Thanks. Yeah, because it is 2 plus 2. Basically, it is 2 plus 2. I'm substituting. It will be 4. Yeah, I got it. Thank you. So now let's go to the next one. So next one, basically what I'll, yeah, thanks. So here I'll be writing my second. So same way I have to examine for x minus 2, for x less than 2 and for x greater than or equal to 2 at x is equal to 0. At x equal to 0, I have to do it. So basically now I have to find my limit x tends to like I have to find it for 0, right? So 0 minus f of x. So basically my left hand limit. So this point is for x less than 0, my function will be 1. So limit x tends to 0 minus 1. I'll be getting my function as 1. Okay, now what about my right hand limit? So limit x tends to 0 plus f of x. When I look at the limit x tends to 0 plus f of x, what is my function value for x greater than 0? So 0 plus means right hand limit, it should be greater than 0. So which means x minus 2 is my function. So limit x tends to 0, x minus 2. So if I substitute the value of 0, it will be 0 minus 2. That will be equal to minus 2. So as I already told you, your right hand limit and your left hand limit is not equal. If it is not equal, from the thing we can say 0 minus f of x is not equal to limit x tends to 0 plus f of x. So in this case, I already told you here, right? If your right hand limit and left hand limit, if both are not equal, you can say it directly, it is discontinuous. You need not find the function value at the particular point. Since I found two things, I can directly say my f is discontinuous at x is equal to 0. So I can say my x is discontinuous. In this case, I can say my f is continuous. So yes, that's all for today's class. I hope you understood what is a continuous function and what is left continuous, right continuous, and another point. And we have solved two sums. And do let me know what you want for teaching. I mean a quick wrap up teaching in YouTube, so that I'll be able to make a new video of it or new content regarding it. So do comment below, so what all videos do you want, so that it will be very helpful for me for making the videos. So yes, that's all. Meet you in next session. Until then, it's bye from Harismita. Thank you.